Hi guys, welcome to another episode of the Power of Logic. So today, I'm gonna introduce you guys a really funny thing. We can find what is the value of the derivative of the antiderivative from a to b f of x of f of x for any of f of x. So now, first, let's talk about what is d over dx? What is d over dx? Let me expand it a little bit. Wait, doesn't really work. So d of dx is basically equal to, it's basically the derivative. And what does this thing exactly mean? So I know that's derivative, okay? But what does that even mean? Okay, what does that even mean? What does that tell us? What does the derivative really tell us about any information about a single graph? So let's see. If I have a line here, now I'm just gonna draw a line. If I have a line here, no, actually not. I'm not gonna use this. Just gonna use the drawing tool. Oh yeah, I have like two lines. Okay, this is basically just x and y axis, axes, and let's say we have a function like this. Okay, and then it's going like this function that looks like someone's dancing, right? Okay, so the derivative. Let me expand it if I cannot. Let's say we want to take the derivative of at this instant. What does the derivative of that instant mean? It basically means the slope of the line that's tangent to this graph at that instant. Let's say we have uh let's say if a function f of x is basically equal to x squared. What this two looks very funny. And then the derivative basically just looks like this. The derivative of f of x is like this. And what does that even mean? What is this? So basically this is just equal to f of 2 minus this thing is basically just equal to f of 2 minus f of 0 over 2 minus 0. The slope of this line, okay, which is equal to 4 over 2, which is equal to 2, right? So this is the slope of that line, of this line at that instant, okay? Okay. So let's erase these things. So basically, we can know that this is the instantaneous rate of change at that moment. Wait, what just happened? What just happened? What just happened? Okay, so now let's look at something. So we know that if the derivative of the instantaneous of that instant, so basically the derivative of x squared, if we have if we can written as x to the nth power, it's basically equal to n times x to n minus 1 power, the n minus 1th power. And if we have the derivative of axn, then this is basically equal to a times n times x to the n minus 1 by using our power rule over here. So now, things we still need to gone to the antiderivative, so I'm just gonna tell you guys what are trigonometric derivative. So we have a sine x. Sine x is basically equal to, so if the derivative of sine of x is equal to cosine of x. And then, but people might say that the derivative of cosine of x equals sine x. No, it's equal to negative sine x. And then from this equation, the amazing part of calculus is that you can just try to speculate for any of the other four trigonometric functions from this. Okay, like let's say if we have tangent, then tangent is basically just equal to the derivative of sine over cosine, which we can just derive the quotient rule, which is therefore equal to cosine square x plus, because we know that the derivative of cosine x is equal to negative sine x plus sine square x over cosine square x, which is equal to 1 over cosine, which is secant square x, because 1 over cosine is secant, and this is equal to secant square x. So now we know that what is the derivative. Let's talk about antiderivative. What is an antiderivative? So as you can see, by interpreting through this word, anti means opposite, right? The opposite of derivative, which is the inverse of the derivative. So what does that even mean? So let's say we have a function. The derivative of this is equal to x, okay? You want to find an antiderivative. So basically we just want to make like this kind of mindset. Let me raise this. So we have a function f of x. The derivative is basically f comma x. Okay. And then if we want to take some antiderivative of something, basically we just take the antiderivative of that derivative and we're going to find the original function that you took derivative from, which means that we want to say that the antiderivative of this is basically equal to f of x. So let's make some examples. Let's say we have 2x, okay? Y is equal to 2x. You want to take the derivative, you want to take the antiderivative of this, okay? 2x dx, this is basically just equal to, we can just basically construct something like this is equal to what of this, take what the derivative of what is equal to 2x. That's basically what the mindset is. And this is by using the power rule, we can see that this is equal to x squared. So the antiderivative is basically the antiderivative, sorry, my mistake. The antiderivative of any number, if you can express it in x to n power, and x power should equal to a times x to n plus 1 power divided by n plus 1. This is the rule, okay? Okay, so antiderivative was basically the essential idea of integral. Okay, so we have talked about most of things about what is the derivative, what is the antiderivative. Now, let's draw the conclusion. What is the value of the derivative of the antiderivative of the, let's say we have the antiderivative of the derivative of the antiderivative, sorry, I made a mistake, of the antiderivative of f of x, f of x in respect to x. Okay. So what is even this? What is even this? What is even this? What is this? So basically this f of x is no matter what it is, okay? So now let's say that we can make f of x equal to a certain, so basically f of x is a derivative. This is a derivative, okay? So f of x is a derivative. So now we know that the antiderivative of f of x is basically just what is the function that if you take the derivative of a function equals to f of x. So basically this is the so basically this becomes the original function. Okay. So you take the derivative of the original function, you will get the antiderivative of the derivative of the function. So you simplify this, and becomes derivative, the antiderivative of the derivative of the original function of f of x. No, as say f of x is basically the derivative of g of x. Then we just find what is this in terms of g of x. So the derivative of the g of x is basically equal to the antiderivative of the derivative of g of x is basically equal to the antiderivative of f of x, right? Which is equal to g of x. So that sounds pretty simple, right? So basically, you can say that these two cancels out, right? Because you take the antiderivative of the derivative, basically the original one. And and even let's say that we can try if we opposite the order, that if you want to find the derivative of the antiderivative of f of x, and what is even that? And we take the, yeah, we just take like that, okay? So if we have like something like this, then this is basically just the antiderivative of f of x, and we derive the same idea that f of x is the derivative of g of x. Then we get that this is basically just equal to the derivative of g of x, which is equal to f of x. Okay. But if you have this cancels out, so basically these two just cancel out and you still have f of x, right? So this is pretty fun. So if you even if you opposite the order, you have to take the derivative first, then the derivative of f of x is basically just the derivative of f of x. And you take the antiderivative of f of x of the derivative of f of x, and then you make sense that if you take the derivative of f of x, you get f of so if you take the derivative of f of x, then you get the derivative of f of x, right? So the order doesn't matter. So basically these two just cancels out. Thank you for watching. See you next time, and have a great day.